Here we go. Okay. All right, back to the desktop. So, and that's what an annuity is, and the sort of the time value money calculations that we're going to be using with regards to questions about annuity typically are going to be present value, and the question you'll be answering with the present value calculation is, what should I pay for this today based on this series of payments that you're going to get in the future. The other question that you might want to ask is, based on a cost today and a series of payments in the future, what is the equivalent rate of return? What's the average rate of return? So you can use the rate function for that. So I'm just going to show you a couple examples with annuity right now. So let's see, do I have one here? I gotta make one up. Okay, so let's say that in the future, you're at your retirement age, the golden age of 65, which we all hope to retire at, I'm sure. And you say, wow, I think I'm gonna live until 85, which is a little bit more than the average life expectancy of people in the United States on average. And so you say, I need 20 years of income. And I think I need, in addition to my other assets, that I need $1,000 a month to pay the bills. And so I wonder what it would cost me to, I wonder what it would cost me to get an annuity that would pay me $1,000 every month for 20 years. So this is the way we're going to figure it out. And again, I'm just going to use these cells here, and I'm going to put the information in the cell and then use the function. So first of all, my NPER, so this is on a monthly basis for 20 years. So 20 times 12 equals 240. So I have 240 months. Future value is going to be 0, because at the end of this 20 years, you're going to have, there will be nothing. You will have received all of your payments. The payments to you are going to be a positive 1,000 because they're coming back to you. So that's a positive thing. And you think that your average rate of return based on your own investment should be about 6% a year. 6%. So based on this information, what should the present value of it be? What should you be willing to pay for it? So let's see here. Rate, comma, NPER, comma, payment, comma, FV. Let's see if I did this right. That does not seem correct. 16,600. So this supposedly tells me that I should be willing to pay $16,000 for this particular annuity. And I know that's not correct, because essentially I'm going to be, over the course of 20 years, 240 times 1,000, that means I'm going to be getting $240,000 over the course of 20 years. So let's see what's happening here. What is this number looking? 2%, 240, 0, payment of 1,000. All right, I got to play around with this a second. Yeah, that didn't change anything. 6%, 240. Oh, it's because the rate is an annual rate and it should be a monthly rate. So I'm saying if my investments were making 6% a month or 72% a year, this is what it should be. And that might be about right, because if you had invested $16,000 and you earn 72% every year, you'd probably do pretty well. So I need to make this 6% a monthly rate. So we go 6% divided by 12, and that is, let's give ourselves 0.5%. There we go. So that's a much better number. All right, thank you for persevering with me through that troubleshooting. So according to this, you should be willing to pay $139,580 for an annuity that will pay you $1,000 a month for 20 years at an average rate of return of 6%. 6% might be a little high, so if you say your average rate of return would only be 4%, which is maybe what these companies who are trying to sell annuities would tell you, then are you going to be paying more or less for that annuity at a 4% average rate of return? What do you think? Your rate of return went down from 6 to 4. You're going to be paying more or less for that annuity? More. Janelle says more. I agree. Let's see. Yes. So because you're making less, or the assumption is that your rate of return is less, then you're going to need to put down more upfront to get that annuity. So this is a way that this is a tool that you can use to make a decision about whether or not for you an annuity, a particular annuity, is a good investment. If you think that you can get 6% investing on your own over the course of 20 years, average 6%, then you shouldn't be willing to pay any more than $139,580 for that annuity, because you can do the same thing yourself, and it will cost you less if you can earn 6% or greater return on that. On the other hand, the one thing that an annuity will do is it locks that average rate of return in. So then you need to consider how likely it is that you're going to meet or exceed 6%. And if you're real sure and want to live with the risk, then hopefully you're going to be earning, it will cost you less than this. But I would say if there's any uncertainty that you're going to be able to maintain an average rate of return of 6%, and you have the option to lock in 6%, I'd probably do it. 6% on average is not a bad rate of return over a long period of time. So this is one way to calculate the present value of an annuity. And the other thing you might want to calculate with an annuity is what the average rate of return that you would be getting by buying an annuity. So you'd use this rate formula down here. So let's use the same numbers here, 240, 0, 0. And payment, we'll say the payment is the same, 1,000. But let's say, so the present value is going to be the cost to you. Let's say the cost is $157,500 for this particular annuity. Oh, this has to be negative, by the way, too. Negative. So if that's the case, and you're getting the same returns as you were before, what is the rate that you would be getting? Well, let's see. What's the average rate of return? N per, comma, payment, comma, PV, which is your price, comma, FV, and that's all you have to put in. You never have to put in type or guess. I mean, you could if you wanted to, but you don't have to for this class. So let's see, 0.38%. So that's on a monthly basis. So if we want to figure out what it would be on a yearly basis, we take this and we multiply it. Whoops. Try not to hit other keys while we're doing this. Multiply by 12, And it says that's an average rate of return of 4.54%. So this is likely what you would be using to determine whether an annuity is a good deal for you, or excuse me, at least what interest rate that annuity is paying out on average is the rate formula. Because you would call one of these companies, you would tell them what you wanted, they would give you a price for it, and then you could use this rate formula to calculate what equivalent interest rate, average equivalent interest rate would be on that annuity. Okay. Okay, any questions about this? This is an annuity, and this is how we use these formulas for it.
That's what I'm doing wrong. I'm still not even getting anything.
So you're hitting equal first?
Because it's already right there, right?
Oh, okay, so you need to, okay, so here's the thing. You have to, these cells are text cells, so they're not going to calculate anything. Click on that right there, that cell, and then do it. See, this is a, well, yeah, just type it in there. Just start typing it in there. Yeah, PB.
Rate, right?
Or rate, yeah, sure. Yeah. See, so now you have the prompts down here.
Oh, I was doing this thing the whole time.
Oh, yeah. No, I'm sorry. I had to make it text, or it would give me an error every time. All right. So we just discovered the issue wasn't Excel 2007. It was because, so if you see these where I actually put the example function, like equals PV bracket equals FV bracket, I had to make these text so that it wouldn't try to calculate anything, because if I don't make them text and I just say leave it like that, it'll give me this error and it won't allow me to put anything in there. So I had to create these cells as text cells, which just means it tells Excel not to calculate anything. It's just going to be a set of numbers or letters. So if you're trying to use these by typing it in here, it won't work because they're text cells, text. But if you go move one over, or actually probably go anywhere else on this particular spreadsheet, if it's currency or number or accounting is the type, then it will give you these prompts. So cool, figured that one out. Okay, no questions about annuities then. Everybody's good on that? Okay, so the last time value of money exercise I want to talk about, this is it's higher level, but it's also much more useful in, well, I won't say much more useful, but it can be very useful in the real world, in the non-school world, when you're out there, if you're involved in the finance portion of a company and you're trying to weigh different projects and determine which one your company should do based on some financial information. IRR is a good one to do that. IRR stands for internal rate of return. And basically what this is calculating, it's doing almost the same thing as rate does. It will tell you a percentage rate of return, except it's doing it, or you can use it to calculate the average rate of return on an uneven set of cash flows. So with the rate cash flow here, you're essentially saying, okay, my return is going to be $1,000 a month, and I know it. It's going to be the same every month, 1,000. So doing an average when the cash flow is the same every month is pretty easy. But when you have projects that the cash flow may be, like many projects in business, you do your investment at the front end and you won't see an immediate return. It will be like a slow build type of thing. If you upgrade your spa facilities, this will be an example we're going to do tonight. If you upgrade spa facilities at a casino or at any other place, it's going to take a while for the marketing to take effect and the word to get out before your customer numbers and your revenue starts ramping up. That's your hope. is that people are attracted to it once they find out that you have new spa facilities. And so you need to be able to calculate what the average rate of return is based on cash flow that's uneven, that starts low and maybe goes high, or maybe even goes the other way, starts high and goes low. And so that's what IRR can allow you to do. It averages out the return based on these cash flows. And the way that you use IRR is to, just like we use these functions up here, it's equal IRR. And then what you need to give it is a series of, well, first of all, you need to give it the initial investment. So again, if money's going out, then that's going to be negative. So I'm going to do this for project X here. So initial investment is the first value, negative 100,000. And then the other values are the return, what you expect to get back based on that 100,000 investment, or all these other. So Y1, Y2, Y3, that means just year 1, year 2, year 3, etc. And so I put those in there, and I hit enter, and hopefully it will not tell me. Why are you not telling me that? I think I ran into this problem before. Oh, what's going on? This is of the wrong data type. Really? Let me try this. No. Oh, I thought I knew how this one worked. Values C30. That's what that is. Let's see something.
Will it work if you do the whole range all in one shebang?
Yeah, that's a good question. Let's see. Oh, you get extra credit. Thank you. Who was that? Who wants those points?
It was Melissa.
Was it Melissa? Patty, you don't have a mic. We know it's not you. What the hell? Nobody wants those points. Thank you, by the way. So, yes, so you select the entire range of both the initial investment and then the subsequent year's investment. So we say project X is 5.55% based on this. So what this means is that they're investing $100,000, and then in year 1 they're making $10,000. Year 2 they're making $20,000. 3, 4, and 5 they're making $30,000 a year off the investment. And the second investment has the same, or the second project has the same initial investment, but the cash flow is different. I just want to see something here. Okay, so, oh, that's not percentage though. It's a number. So in this case, the total return is $120,000 over 5 years. This one also earns $120,000. So that over the course of 5 years, they earn the same amount of money, but they do it in a different fashion. This one earns $5,000 the first year, 20, 30, 30, 35 the last year. So before I do the IRR for project Y, do you think it's going to be higher or lower rate of return than project X? They both earn the same amount over 5 years, but in different time periods. Letitia, what do you think? Higher or lower? Project Y?
I'm thinking.
I can tell by your forehead. It's all crinkled.
Is it?
Kidding. Well, just guess. Higher or lower? Come on.
Are you sure?
Yeah, I'm sure.
I would say lower.
Lower. Why do you think it would be lower?
I don't know, because the numbers.
Because the numbers. Wow. I'm going to ask you to write an essay about this. Why it would be lower? Because it is going to be lower. I'm pretty sure. Let's see though. IRR. Oh, whoops. I included one too many cells there. I included the 120,000 at the bottom. There we go. Let's do 35, 5% with 2 decimal places, 5.27. It is lower. Anybody have an idea why it's lower than Project X based on those cash flows?
Just looking at it, how do I say, like, the numbers are different. So like for 10,000 there's 5,000, so that's half of it. But then it comes up at the last with, instead of 30 it goes to 35,000. So that's why I was sitting here looking at it, and it's kind of, to me it seemed like one of the trick questions or something. But
I wouldn't say it was trick. It was tricky, maybe.
yeah. But
So you sort of highlighted the reason why Project Y has a lower, slightly lower rate of return, because you get less money in the near future and more money further out. Whereas Project X, you get more money next year in year 1 and less money in year 5. And the reason that it would cause it to be lower is because of this whole compounding thing. Every year you expect that you are going to, your average rate of return would be 5.55%. And every year that you have the money longer, you would have the opportunity to make more money off of it. And so if you have more money in year 1 than for Project X than Project Y, and everything else is the same, even though Project Y gets more money in year 5, then it's going to have a higher rate of return because you get a bigger return sooner on your investment. So if we do something here, I'm just going to move this 35. We're going to change this around a little bit. Instead of year 5 making Project Y making 35,000, we're going to say year 4, 35,000. I'm guessing the rate of return here is going to be a little bit higher than 5.27%, which is what it just was, because we're moving the money closer. Yeah, so it's 5.34. And if we move 35,000 to the year previous, should be a little higher, 5.40. So as you move the money back closer in time to you and you're earning it closer, then that increases the return on the project. They both still pay out 120,000 over the course of the 5 years, but the project that pays out more sooner is going to have the higher internal rate of return. So, and again, the internal rate of return is just the average rate of return over, in this case, 5 years, based on these different cash flows, these different returns that are paid out each year. Okay, any questions about that? The internal rate of return, what it means, how you calculate it. Thank you, Melissa. You do have to select all cells. So the negative cell first and then all the returns. And that will allow you to calculate it here. No questions? Okay, so If there are no questions, oops, then let's do the exercises. So this is the last thing we're going to do in class is these today. We're going to have class again next week, by the way. We're going to do some in-class exercises. So in week 9, there should be right next to that blank Tgbm calculations, right beneath it, there's something called in-class time value of money calculations. So what we're going to do is, does everyone know how to send a private message? You probably do. You've probably been messaging each other off and on, and I haven't even seen it. Complaining about my teaching and all this other crap. If you don't, you're gonna. I want you to know, because this is how you're going to submit your answers this time. This is we're going to do this in class. Whoa. Pardon me, my screen just went weird. I'm going to do these in-class exercises, and I'm going to have you submit your answers to me. I'm going to stop the share. So anyways, what you can do here, let me see if I can show you. Maybe. I don't know if I can show you with this window open. Oh, there we go, chat. Okay. Okay. So basically all you have to do is find me on here. You can't see me now because I'm talking to, because I am me. I can't message myself. I do that in my head. But just select my name here, right? And then you type something like, good to see your forehead, or something like that, whatever. And then it will go to the person that you sent it to, right? So send it to me. My name's, I think I'm registered as S. Zawoski here or something. The only one with that last name. So what we're going to do here, because this is good for like points. So this is an opportunity to earn some extra credit. Whoa. Here, let me mute you. Oh, you're supposedly muted. Just a second.
Is it because I have
We're getting some feedback here.
do you want me to click it out?
Oops. So these actually have these have mics too. Okay. All right, we took care of our feedback problem there. Anyway, so what you're going to do, I would keep your Excel spreadsheet open with that, all those great formulas in there, and basically there are 1, 2, 3, 4, 5, 6 questions here. Time value money exercises questions, and so each of them 6 times 5. So each of them I'm going to give everybody 5 minutes, and then you're going to submit your answers to me via private text. You could do it via public text, but then other people might copy it, and that might either be good or bad depending on your answer. So submit them to me via private message on the chat thingy. And then I'll give you some extra credit points for correct answers, and then after each one of them, I will give you some feedback. So actually, you know what? We're going to say, you don't need 5 minutes for each of them, do you? I don't think so. I'm going to give you 3 minutes, because I think 3 minutes is great. No, 4 minutes, right in between. Sorry.
Can you say the first question on there just so I know that I'm in the right doc?
Yes. Yeah, so the first question is, you invest $200 per month in your IRA for retirement. If you do this for 20 years and your IRA has an average rate of return of 6%, how much money will you have when you retire? Is that the one? Should be under week 9.
There's 6 questions.
And there are 6 questions on it, yeah. So we're going to say 4 minutes for each one of them. And then I'll briefly give some feedback, and then we'll go on to so we're going to do these one at a time. We'll do 1, and if you're done, you can certainly start working on number 2, but I'm going to give everybody 4 minutes to work on it, and then I'm going to go over it to make sure everybody has an opportunity to understand it if they didn't, and excuse me, and then we'll move on to the next one. All right, does that make sense? Am I making sense tonight? Okay. All right, so let's start with, oh, let me get my little timer out here. And this is all for extra credit, so no reason to stress out about this. This is just good practice. All right, so we're going to say, we're going to start on number 1, and which is the one about the.
Is that like a 2-part question? Or no?
Oh, right. Yes, it is. So let me see here. How many 2-part questions do I have in here? All right, here's the deal. We're just going to do the first part of each question. So questions 1, 2, 4. 1, 2, and 4 have 2 parts. We're only answering the first question in there. So for this first number 1, for instance, we're only answering how much money will you have when you retire, not the part about what if you started earlier in your career and invested this amount for 30 years. So just the first question in 1, 2, and 4. All right, any questions before we get started on this game show time value money exercise? All right. You have 4 minutes. Go. I wish I had some like Alex Trebek music to play right now. And remember, just private message me or private chat me, whatever your answer. Oops. 40 seconds. You don't have to wait until 4 minutes to chat me either. So, excuse me. Or whatever the verb for that is. All right, 5 seconds. Oops. All right. Stop. According to, let me make sure. Edna, I'm really sorry. I was wrong. It is future value. I don't know what I was saying there. I actually used future value, and I told you it was present value. So, my bad. It is future value, definitely, is what you're figuring out here. And it appears to me that only one person got it correct, and it is $92,408. I guess I need to, I will, whoops. Let me just share my screen real briefly here. Show you. All right. So it's a future value question. You're finding something in the future. But this is one of those ones where you have to think in months, not years. And so the rate and the time periods both have to be in months. So the rate was 0.5%, which is 6% divided by 12. So that's your monthly interest rate. The number of time periods was 240, which is 20 years times 12 months. And then your monthly payment is -200. You're shelling out $200 a month. So it should give you this end result, $92,408.18. Okay. Any questions about that? The tricky part about this one probably was the fact that it was months, not years. So just remember, whatever time period you're doing, if it's months or years, both the rate and the number of time periods has to be that same amount. So if we were figuring this out in years, the rate would have just been 6%, and the number of time periods would have been 20. Okay. Okay, so that's the first one. All right. So let's move on to number 2. So you have found a wonderful home and are interested in buying it for $275,000. No down payment involved here. If the bank is willing to give you a 30-year loan at 3.75% interest, what would your monthly payment be? Remember, key, monthly payment. Monthly. All right, go. 4 minute. One person has got it so far. You've got a minute, 60 seconds. Thirty seconds. Two right answers. All right, everybody submit their answers. It's 4 minutes. Let's see here. No, all right. So the answer was 1273.57. So show you. Oops, not that, but this. So this is, again, this is a monthly calculation. So you got to have your time period and your interest rate in months. So I took 0.0375 divided by 12. It gives me a monthly interest rate of 0.31%. Number of time periods was 360 because there's 30 years times 12 months. And then the present value amount that you're getting financed is $275,000. And at the end of this period of time, the loan itself will have a zero balance. So the future value is zero. So that gives you 1273.57. Any questions about that one?
I didn't put the interest in the decimal point 0.375.
Oh,
I just did
3.75.
divided by 12.
And what did it give you for a rate then?
Um,
I'm just curious.
31.25%.
Oh, yeah.
Sounds like you.
Yeah. Yeah, so watch your decimal points there. Yeah.
So you wanted us to take that out to 4 place values then, instead of 2 for the dividing by 12?
Well, so because this is a percent, to get an actual 3.75% is in numbers 0.0375. Yeah, so you would have to go out there. Did you just go to 0.04?
No, I did that. That's why I'm trying to figure out why I'm off.
You did go to 0.0375 and divide by 12?
Yes, and then I got the 0.31%
Right.
for the rate. Got that.
And you got 360 time periods.
Yeah, but I put a negative 275 for my present value. Why would that throw me off?
It shouldn't. Yeah, it should just give you, it shouldn't. It just gives me a positive 1273.57. You don't have anything in future value or payment?
I have 0 for future value.
I don't know. Unless it's a round, I can't imagine it would be a. So when your interest rate displays 0.31%?
Yes.
And everything else looks the same as those things right there?
Yes, in fact, it does. That's really strange.
Wow. Huh. Yeah, because your answer was very close, but it was like, what was your answer again?
I think it was $5 off. 1273. No, I got 1268.89, which is about $5 off. So
Weird.
oh, okay.
I don't know. Sorry, yeah, I don't know what's going on there. That's strange. Okay. So that was number 2. Let's move on to number 3. Whoops. Which is, as you near retirement age, so this is an annuity question, annuities begin to look like an attractive investment to provide regular retirement income. One company offers an annuity that pays $1,500 per month for 20 years. They charge $150,000 for this annuity. What is the average rate of return on this investment? All right. I'm going to set my timer for 4 minutes so we get a nice jingly bell. All right, go for it. And you can give me your answers either in monthly average interest or yearly average interest. It's up to you. All right, got about 40 seconds. Uh-oh, there's the bell. Twinkle time. All right, so Send me your answers now if you want credit. I only have one answer. Oh, two. Wow, Melissa, you are like off by a little amount. I wonder what's going on. You're literally off by 0.04%. What form are those cells that are you using the spreadsheet that, the blank spreadsheet that I sent, or that's on the website for the time value money?
Yeah, I'm using that blank one. Maybe I should be using my own blank one and my own 2013. Do you think that would be a better idea? I don't know.
Yeah, try it.
Okay.
It seems like there's some rounding error going on there because that's so close. All right, so just two answers for that one. So the answer was 10.52%, at least in Excel 2010. And let me show you. All right, so right here. So again, this was I gave you the payments per month. So everything else has to be in a monthly basis. In this case, it's just the number of months. So 20 years at 12 months a year is 240 months. Future value of 0, you're not getting anything in the future. Right now, it's costing you $150,000, negative 150 present value. In exchange for that, you're getting $1,500 a month for 240 months. That gives you a monthly interest rate of 0.88%. or a yearly interest rate of 10.52%.
Like put it in the formula because I put them in and I didn't get nothing close to that, so I'm not sure what I'm doing wrong.
I'm sorry, can you say that again?
Can you highlight your answer, the 0.88, so I can see exactly where you put everything? Because for some reason mine's not coming out to that.
Yeah, so these were the arguments that were put into there. The 240 number of time periods, 0 future value, negative 150,000 present value, and positive 1,500 payment. What answer did you get for that one?
I got 1%, but I didn't put in the 0 for future value, so I think that's probably what, I don't know why. My numbers are all the same, just like yours, but the
Okay, so the other thing you got 0% for the rate?
No, I got 0.1, or I got 1%.
1%. Okay, so what you might need to do is go up here and right like this and add another decimal place and see if you get 0.88 with this button right there. Increase decimal. When you increase it to 2 decimal places, do you get to 0.88%? Because I don't think it matters whether there's anything in future value. Yes, and so this gives me another opportunity. If when I was grading homework over the weekend, one of the things I did notice happening a lot, and so I think everybody got a reminder about this at least once. Everything, both percentages and real numbers, should go to 2 decimal places. So give me all your answers to 2 decimal places, no matter what it is. Round up to 2 decimal places.
Okay, yeah, so I got a 2013, so it automatically rounds it up, I think, for me on my Excel.
Okay.
That's my problem. I figured it out, thanks.
Okay, yeah, if it goes out to 2 decimal places, hopefully you get 0.88. If it's at 1 decimal place, I guess it'll give me 0.9%, but it'll round off. So, okay. How about number, so let's see, that was number 3. Let's go to number 4, which says the U.S. government is selling a 10-year bond that will pay $1,000 at maturity. If you are seeking at least a return of 4% annually, what is the maximum you would be willing to pay today for this bond? All right. So, all right. Start. Well, you could have started before this. That was fine. You got 4 minutes now. Let's see. Oh, you can see all the answers. You can see me doing my answers, can't you? Can't do that.
No, I'm trying to take notes so I know which one you can.
Oh, but you're logged into Zoom too, right? So you can see me when I share my screen.
Yeah.
Nice. 1, 2. 2 correct. 2 for 2. We're 2 for 2 so far. 2 correct answers. Janelle is going to use my work. Let's see. 3 for 3. Yes. Practice makes perfect. You guys should start buying bonds, I guess. Let's see. "30 seconds." All right. Time up. Submit your answers if you want credit, or your guesses. They're all answers, really. We got 3 right so far. That's it? No? No moss. Okay. So the answer is $675.56. And let me show you how that works. Right here. So it's a present value question. It's asking what would you pay for something today. So you want to figure out present value, and it gives you, it's going to pay you $1,000 in 10 years. So this is a year question. So everything should be in years at an average rate of 4%. So you don't have to divide your percent or multiply your number of years to convert them into months for this one. It's straightforward. So, and there are no payments. So you should be willing to pay $675.56 for this one. The second part of that question, just because someone sent me a question about this, how would you do that second part? Second part to the question says, if I can talk, what would you be willing to pay if the bond also paid an annual coupon of $20 for 10 years? An annual coupon is just an amount of money that you get paid in addition to the $1,000 at the end of 10 years. And that $20 would go here in the payment. And so you would put 20 in there. Once again, it's positive because it's coming back to you. And you put this in, and it's going to change that $675. Should change it up because you're getting more money in the end. Let's see what it does. Yeah, it changes it. You should be willing to pay $837 for a bond that pays you $1,000 in 10 years and a payment of $20 every year at an average interest rate of 4%. That's what you should be willing to pay for it. $837. Okay. So that's the second part of that question, but you didn't have to do that. All right, so on to numero 5. Yes. General Electric is selling bonds that pay $5,000 at maturity in 5 years. The bonds are currently selling for $4,173. What is the equivalent interest rate for this investment? All right. 4 minutes. You guys are going to want to like join game shows after this or something like that. All right, I got one correct answer. We're 1 for 1. Let's go 4 for 4 at least right now. 2 for 2. Two for 3. All right, 5 seconds. Here it is. All right, anybody else want to throw out an answer there for me? No. All right. So the answer, I believe, is 3.68%. And get that out of the way. So the way I figured it out. So this is interest rate. It's asking what the equivalent rate of interest is, right? What was the question again? What is the equivalent rate of interest for this General Electric bond? And so number of time periods, it's in 5. It's a 5-year bond. So the number of time periods is 5. The future value is 5. They're going to pay us $5,000 in 5 years. And the present value, the cost that they're asking for that is $41.73. So that's what you would have to pay. So that's a negative. So when you put those in there and use the rate, gives you 3.68% on an annual basis. Questions about that one? You're going to get more more opportunities to practice this week. So you're going to have another assignment sort of like this. Also, and this is just a little computer hint. If you have, like, right now I have like 4 windows open maybe. It's a real pain in the butt to like be clicking back and forth between these all the time. So one thing that you can do is you can hold down your Alt key and then hit Tab, and it will like scroll through these, and so you can go through there and say I want to be right there, basically. So you may have already used that feature, but I like it a lot. So I use it all the time because I have like 4 spreadsheets and 2 Word documents and my email open. Anyways, all right, number 6, last one, then we're done. The Silver Reef Casino is considering whether it would be better to invest in an upgrade to its spa or additional slot machines. Both projects would cost $250,000. The returns on the projects are listed below. Which project earns a higher return? So, big hint here, you want to use that new function IRR and keep it in the same format. All right, good luck. This is Final Jeopardy. Go. I will never have a mustache like Alex Trebek, though, I'll tell you that. Let's see. And this one I'll offer 2 points. 1 for the correct answer, which project earns the higher return, and 2 for the actual return that it earns. So the first one you can just guess. Second point, need a number.
Make it, because I
What's up?
make it a text. So I changed the numbers in there from here. Because it opens up in Word, right?
Mm-hmm.
You want to use this.
Mm-hmm.
So this one, we want me to change it to percent. I mean, to text. So I can use this. For this one. Mhm.
I don't know why.
Oh, now it does.
Yeah. And the other thing you can do is just highlight them all and go up here and do the number. Make sure they're all numbers.
Okay.
All right, so you can have an extra minute on this one because there's more calculations, and I may only have 1 correct answer. We'll see. Or maybe 2. I got 1. One correct answer. Melissa, I need it in 2 decimal places. If you can do that, you're good to go. Anyone else want to throw one out there? Give me about another minute. Well. Yes, Melissa. Thank you. Oops. All right, anyone else? Actually, let me do something real quick here. You are a geek, that's for sure. It's good to be a geek, though, really. It pays off in the long run. You may not be as cool when you're in, high school and stuff, but being a geek pays off in the long run. Okay. Private conversation there. So the answer is you would want to do, not Project Y, but you would want to do the slots. because the slots earn you 14.08% average return on investment, and Project X, the SPA, earns you 12.84%. So I noticed that one person had like 10.42%. And I think what you did there was what I initially did, or 8.42. Here's what you did, Janelle. I'm sorry. So you, if you just used the IRR formula that was already there, it only selected years 1 through 5, and it didn't get the last one. And so I had to manually go in here and just update it from, you can either manually go in or you can just reselect the whole thing. But I just updated it to go down to C36, so it got this last year. And that's what gave you 12.84%. So, yeah. All right, so you would want to do the slots, and you definitely, yeah, those are the percentage rates of return that you got for that one. Any questions about IRR or that calculation? No? Yes, I believe so, Andrea. Yeah, so you need to select all through year 6. Okay. So that's all we're going to do for tonight. Stop this, stop this. There we go. And so for this week, a short week, I'm going to have one more batch of these time value of money exercises for you. I'm going to have a writing assignment based on the Native Nations Institute module, because one of the assignments for last week was to get done with that module. So if you're not done, you might want to complete it. And then again, just make sure you are familiar with the information in Chapter 6 about interest rates, because we're going to start on that on next Monday. And it can be a little bit difficult to understand, so I really encourage you to read it first, even if it's confusing, before we go over it, because it will at least give you some basis for what I'm going to be talking about on Monday. So that's what we'll do next Monday, is interest rates. Might do a little bit of Chapter 8. And then the week after that, I believe, unless my calendar is off, we only have class next Monday, and then one more class after that, and we're done. So that last class will be test number 2 on I want to say December 7th, I think is the class after next week. So 2 more classes. So we're almost done. So I'll post those assignments hopefully tomorrow for you. So if you want to work on them before the long weekend, you can. Any other questions before we sign off for the night?
Did you get to break the extra credit test?
I haven't graded the extra credit test yet. So I did get a good amount of grading done last weekend. I'm going to do more this weekend. So I'm hoping, my goal will be by Monday to have all the homework graded. So I will be getting everything that you've submitted but not gotten back to me. I'll have it graded by next Monday. Be my priority. All right. Any other questions, comments?
Can you share your screen from the last question, please?
Uh-huh.
Look at it one more time.
Yeah. So this is the equation. It's IRR equals all of this. And then the same for this. So you're going to have always the first entry in these IRRs needs to be negative. It needs to show what the investment is, the money going out. And then everything else included in there needs to be positive. So returns on those investments for it to calculate correctly. That makes sense? Okay.
It went from bottom to top, so I think that's why mine doesn't.
Oh. Huh.
Yeah, Okay,
Did
thank you.
Did it give you an error or just a weird answer?
Just a weird answer, way off from the correct one. So
Oh, okay.
I got it now. Thank you.
All right. Anybody else? All right. Well, have a good weekend, long weekend. Enjoy your time off. If you have any questions about the homework or anything else during the week, you can send me email. I will be checking that through the weekend. And yeah, hopefully we'll see you next week for our last real class session.
What kind
All right.
of assignment late then?
Yes, you can hand in your assignments late. If you noticed, if you did that and I graded it, I do mark you a certain amount off. So, but they're still worth points. So if they're late, I would still encourage you to submit them.
Now that I know what I'm doing.
Yeah.
Okay. I'll have to
Thanks.
go.
You too, Patty. Have a hell of a good Thanksgiving.
Happy Thanksgiving. Have an Excella one.
There you
Okay,
go.
I'll see you later.
All right. Geek. See ya.